I will explain what is Arrhenius acids and bases. Arrhenius acid is increases concentration of hydrogen in an aqueous solution. For the example of Arrhenius acid is hydrochloric acid. For the next one is Arrhenius base. Arrhenius base is increases concentration of hydroxide in an aqueous solution. For the example is sodium hydroxide.
Alright, thank you. The next one, I will explain the Bronsted-Lowry acids and base. The first one, Bronsted-Lowry acid, is equal to proton H plus donor. For example, HCl donate H plus to H2O. Alright, the second one is a Bronsted-Lowry base. Is a proton H plus acceptor. For the example, H2O accept H plus from HCl. Thank you.
Assalamualaikum and greetings to all of you. For this slide, I will explain to you Lewis acids and bases. The Lewis acid-base theory is a broader and more general theory compared to the traditional Bronsted-Lowry acid-base theory. It focuses on the behavior of electron pairs during chemical reaction. Number 1, Lewis acid. It said that accept an electron pair. What does it mean? Okay, a Lewis acid is any substance that can accept an electron pair. In other words, a Lewis acid has an empty orbital or is capable of accepting electrons from a donor. These substances are electron deficient and seek to complete their valence shells by accepting electron pairs. For example, BF3 accept electrons. BF3, in the case of BF3, which is it's called boron trifluoride, the boron atom has an incomplete octet because it only has 6 valence electrons. As a result, it can accept an electron pair from a Lewis base to complete its octet. This makes BF3 a Lewis acid. Number 2, Lewis bases donates an electron pairs. What does it mean? For Lewis base, a Lewis base is any substance that can donate an electron pair. Lewis bases have lone pairs of electrons, which is, we can call it non-bonding electrons that they can share with a Lewis acid. These substances are electron-rich and look for ways to share their electrons with an electron-deficient species. Number 2, Lewis bases donates an electron pairs. What does it mean? For Lewis base, a Lewis base is any substance that can donate an electron pair. Lewis bases have lone pairs of electrons, which is, we can call it non-bonding electrons that they can share with a Lewis acid. These substances are electron-rich and look for ways to share their electrons with an electron-deficient species. For example, NH3 or ammonia has a lone pair of electrons on the nitrogen atom. This lone pair can be donated to a Lewis acid to form a coordinate covalent bond. As a result, NH3 acts as a Lewis base. So we can summarize that Lewis acid, which is, we can call it an electron acceptor for Lewis acid. For Lewis base, we can call it electron donor because it donates an electron pair.
Neutralization reaction HCl and KOH. Reaction HCl plus KOH equal to HCl plus H2O. Step 1. Calculate mole of HCl. Mole, molarity at volume. Mole 2.50 m at also at 0.050 0.00 L equal to 0.125 mole. Step 2. Determine mole of KOH. 1:1 ratio. Mole of KOH equal 0.125 mole. Step 3. Calculate volume of KOH. Volume plus molarity. Volume 0.125 slash 0.75 m equal to 0.1997 L and last 199.7 ml.
Seterusnya, slide ini menerangkan tentang step untuk solving a neutralization reaction problem involving hydrochloric acid HCl dan juga calcium hydroxide CaOH2. Jadi reaction, the chemical reaction is yang atasnya adalah merupakan neutralization reaction di mana HCl iaitu a strong acid bertindak balas dengan CaOH2 iaitu base yang kuat. Okey, kemudian cara untuk solve adalah yang pertama, calculate moles of HCl dengan menggunakan formula mole sama dengan molarity darab volume. Diberi molarity of HCl adalah 0.170 molar dan juga volume of HCl adalah 0.100 liter. Jadi calculation dia adalah moles of HCl sama dengan 0.170 molar darab 0.100 liter sama dengan 0.017 moles. Step yang kedua, determine moles of CaOH2. Yang tadi kita tengok calculate moles of HCl. Okey, kita pergi ke step yang kedua di mana reaction ada 1:2 molar. Reaction has reaction yang ada 1:2 molar ratio between CaOH2 dan juga HCl, di mana satu adalah CaOH2 dan juga HCl adalah 2. Jadi moles kita pakai formula ni untuk kira dia. Moles of CaOH2 iaitu calcium hydroxide sama dengan moles of HCl iaitu hydrochloric acid bahagikan dengan 2. Jadi pengiraannya kita dapati moles of CaOH2 sama dengan 0.017. 0.017 ialah moles of HCl, kita bahagikan dengan 2 sama dengan 0.085 mol. Jadi untuk step yang ketiga adalah untuk calculate the mass of CaOH2 memerlukan dengan menggunakan formula mass sama dengan moles darab dengan molar mass. Jadi molar mass kita dapati molar mass bagi CaOH2 adalah 74.096 gram per mol. Jadi pengiraannya adalah mass of CaOH2 sama dengan 0.085 mol darab dengan 74.096 gram per mol sama dengan 0.630 gram. Jadi jawapan akhir untuk neutralize adalah 0.100 liter of 0.170 molar HCl, 0.630 gram of CaOH2 adalah diperlukan.
Next, we will go to hydronium ion concentration and pH. When you know the pH of a solution, you can find out how many hydronium ions, H3O+, are present using a formula. The concentration of these ions tells you how acidic or basic the solution is. Step 1. How to calculate hydronium ion concentration H3O+ from pH. Formula: H3O+ equals to 10 minus pH. If the pH is 2.45, then you plug it into the formula like this. H3O+ equals to 10 negative 2.45 equals to 3.32 times 10 negative 3 m. This means that the concentration of hydronium ions in the solution is 3.32 times 10 negative 3 m. For the step 2, how to calculate pH from hydronium ion concentration, you can use the formula pH equals to negative log H3O+. For example, if the concentration is H3O+ equals to 3.75 times 10 negative 9 m, you plug it into the formula. pH equals to negative log in the bracket 3.75 times 10 negative 9 equals to 8.43. So the pH is 8.43, which means it's slightly basic since pH above 7 is base.
For question POH and pH of NaOH solution, we were given OH minus as a 4.99 times 10 minus 4 mole. Step 1, we have to calculate POH. The formula for pOH is minus log OH minus. So we have to put OH minus inside the formula, and then we will got minus log 4.99 times 10 minus 4 equal to 3.30. Second step, we have to calculate pH. We were given a formula of pH equal to 14 minus pOH. We have to put pOH inside the formula. Then we will got pH equal to 14 minus 3.30 equal to 10.7 T.